Hello everyone, today I'll be explaining the rate law. So first of all, what is the rate law? The rate law is an expression that we use to find the rate of the slowest step in a reaction, which is also known as the rate determining step. So this expression you see in front of you is the expression of the rate law. R, which is the rate, is equal to K, which is the rate constant, multiplied by the concentration of x to the power of n, multiplied by the concentration of y to the power of n. So R, since R is the rate, then the unit is molar per time, and time can be anything, seconds, minutes, hours, days, whatever they give you in the question, you just use it. And K is the rate constant, which I'll explain later. X is the first reactant, and N is its coefficient, and Y is the second reactant, and M is its coefficient. But since here we're using concentration, so X is in molar and Y is in molar. And N is also known as the rate order with respect to X, and M is also known as the rate order with respect to Y. That's why N plus M gives you the total order of the reaction. So now let's solve this simple question. Find the rate law. They gave us two simple reactions. One of them is slow and one of them is fast. And as I said at the beginning, to find the rate law, you only look at the slow reaction. So we only look at this one and we ignore the fast one. X plus 2y gives you Z. The two reactants are X and 2y. So X and Y are the two reactants, and Y has a coefficient of 2. So the rate law would be R equals K times X to the power of 1, because X's coefficient is 1, times Y to the power of 2, because Y's coefficient is 2. So the rate order with respect to X is 1, and the rate order with respect to Y is 2. So the total order of the reaction would be 1 plus 2, which is equal to 3. Okay, so now let's solve this question. For the reaction 2x plus y gives you z, the following results were obtained. What is the rate law for this reaction? So to find the rate law for a reaction like this, we usually never look at the reaction because this reaction has wrong coefficients and they're just put it there to try to trick you. So what we have to do is we look at how the values change as we go from experiment 1 to 2, and how the change in those values affects the rate. And we do that to try to find the coefficients of x and y. So as we go from experiment 1 to 2, x doesn't change, so we don't look at it, but y is multiplied by 2 times 2. And what happens to the rate? It's multiplied by 4. So how does this change in y affect the rate? So 2 to the power of n is equal to 4. So what is n? What is the coefficient of y? It's 2. N is equal to 2. And now we do the same thing as we go from experiment 2 to 3. So as we go from experiment 2 to 3, x is multiplied by 1 over 3, or divided by 3, same thing. Y doesn't change, so we don't look at that. And the rate is multiplied by 1 over 3 also. So 1 over 3m to the power of m is equal to 1 over 3 m. So m is equal to 1. So the coefficient of x is 1. So the rate law for this reaction is r, which is the rate. K equals k times x to the power of m, which is 1, times y to the power of n, which is 2. Okay, so now let's solve part B. Calculate the rate constant of the reaction. The rate constant is K, as I told you before, and to find the rate constant, usually the first thing we have to do is write the rate law, because if you write the rate law, it makes it 100 times easier to find the rate constant. So to find the rate constant here in this case, it's very easy. We just have to take any one of the three experiments. So I'll take experiment 2, for example, and we substitute its values in the equation. So 9.6, which is the rate, equals K times 0.3, which is the concentration of x, times 1.6 squared. And if you do this on the calculator, you'll get K equals 12.5. Now this is not the final answer because when you write K, you have to include a unit. Now to find the unit of K, you have to do molar to the power of 1 minus m minus n over time. Now, if you use this formula, you're always going to get the unit for K. So m and n in this case are 1 and 2. So 1 minus 1 minus 2 is equal to minus 2. So molar to the power of minus 2 over time. So this is the unit for K. We can also write it as molar to the power of minus 2 times time to the power of minus 1. So here we put it next to the K. So this is the final answer here. Okay, so now let's do number 2. For the reaction 3a plus 2b gives you c, the following partial orders were obtained. With respect to a, it's 1, and with respect to b, it's 2. Deduce the unit of the rate constant of the reaction, knowing that the rate was calculated in mole per decimeter to the power of negative 3 times second to the power of negative 1. So what they're doing here in the last statement is they basically gave us the unit for the rate. So instead of using molar per time, like usual, instead of molar, they put molar, it's equal to, instead of molar, they put mole per decimeter cubed, which is true, because molar is equal to decimeter cubed, because C is equal to N over V. Okay, so now let's find the unit for the rate constant. So the first thing we do to find anything to do with the rate constant is you have to write the rate law. So rate law is R equals K times A to the power of 1, because they told you the rate order with respect to A is 1, times the rate order with respect to B, no, times B to the power of 2, because the rate order with respect to B is 2. Okay, so now to find the unit of the rate constant, we can use the formula that I gave you before, which is m to the power of molar to the power of 1 minus m minus n over time. And m and n in this case are 1 and 2, so 1 minus 2 would give you minus 2, so it's molar to the power of minus 2 times time to the power of minus 1. But this isn't the final answer because they don't want it in this form. They want you to use mole per decimeter to the power of negative 3. So instead of molar, we just put this mole per decimeter to the power of negative 3 to the power of negative 2, the whole thing to the power of negative 2 times time to the power of negative 1. So what we do here to get the final answer is we just distribute the minus 2, so it would be mole to the power of minus 2 times decimeter to the power of negative 3 times negative 2, which is 6, decimeter to the power of 6, times second to the power of minus 1, because the time is seconds. Here, so this is the final answer. Negative 1 here. So this right here is the final answer.